Hello everyone, welcome to my channel. So today we are going to discuss about the topic goals and objectives of floor planning, placement and routing of VLSI. Floor planning, placement and routing are critical stages in the VLSI design flow as they directly impact the performance, power consumption and overall success of the chip. This presentation will explore the key goals and objectives of each stage. Here we go into introduction to VLSI design flow. Specification, architecture design and logic design. Specification defines the functionality, performance and constraints of the chip. Then architecture design determines the height level structure and organization of the chip. Then logic design translates the architectural design into a logic level implementation. Then we have importance of floor planning in VLSI design. Chip performance, power efficiency, area utilization, and design feasibility. Chip performance. Effective floor planning can optimize critical paths and reduce interconnect delays. Then I have a power efficiency. Proper placement of power supplies and distribution can minimize power consumption. Then area utilization. Efficient use of chip area through careful block placements and arrangement. Then design feasibility. Floor planning can identify and resolve potential design issues easily in the flow. Then I have objectives of floor planning: area minimization, interconnect optimization, and power distribution. So first we're going to discuss about area minimization. Compact placements of functional blocks to reduce the overall chip size. Then we have to reduce the chip size, power consumption or power distribution, and length of the chip also. Then next comes interconnect optimization. Minimize length and complexity of interconnections between the blocks. Then I have power distribution. Efficient placement of power supplies and distribution networks. Then we have techniques for effective floor planning. We have some techniques for floor planning, that is partitioning, symmetry, hierarchical design, and iterative optimization. Partitioning: divide the design into smaller, manageable blocks for better organization. Then I have exploit symmetry in the design to simplify the floor plan and interconnect. Then hierarchical design: use a top-down approach uh, to pro- to progressively refine the floor plan at multiple levels. Then you have a iterative optimization. Repeatedly evaluate and improve the coverage on the best solution. Next, I have placement, that is fundamental and challenges. We have some fundamental and challenges in this placement. We have congestion avoidance, timing optimization, power management, and legalization. Cons- uh, congestion avoidance: ensure even distribution of cells and interconnects to prevent routing bottlenecks. Then we have timing optimization: position critical parts and high speed blocks to minimize the signal delays. Then power management: group related components to optimize power distribution and reduce the hotspots. Next, I have legalization: enforce design rules and constraints to manufacturable layouts. Then we have placement algorithms and optimization techniques. Partitioning based, then I have force directed, then simulated and analyzing. Then we have partitioning based. Divide the design into smaller, manageable blocks and optimize each one. Then force directed. We have use physical forces to model component interactions and find an optimal layout. Then I have simulated annealing. Iteratively improve the placement through random and acceptancy criteria. Then I have routing, concepts and objectives. Multi-layer routing, wire length minimization, and congestion avoidance, then crosstalk. We have multi-layer routing, utilize multiple metal layers to route complex interactions, then wire length minimization, optimize the length of interconnects to reduce the propagation delay, then congestion avoidance, ensure even distribution of wires to prevent routing bottlenecks. Then I have crosstalk, minimize the coupling between the interconnects between blocks. Then we have routing algorithms and strategies. Global routing, detailed routing, and incremental refinement. We have global routing, determine high level routing paths between blocks, and detailed routing is finalize the exact geometry and track assignments for each wire. Then incremental refinement is iteratively improve the routing solutions to all the constraints. Then I have conclusion and future trends. Floor planning, placements, and routing are crucial steps in the VLSI design flow and will continue to evolve to meet the demands of increasingly complex and high performance integrated circuits. Emerging techniques like 3D integrations, photogenics, and neuromorphic computing will further shape the future of